In Chapter 1, we're going to review topics that you've learned in other courses prior to this class. So the first thing we're going to start with is functions, so understanding what a function is, and some vocab. So we're going to start off with what's called a dependent variable versus an independent variable. So your dependent variable depends on another variable, but this is your y value. So this is the y value or the output. This is also considered the range. So everything you get out, that's going to be your range. And then the independent variable, this is your x. This is independent of the other variables, and it's what you put into a function. So it's the input. And for this, the set of these input values is going to be considered the domain of the function. So it's all the inputs versus the range is all the outputs. And then we talk about what's called a relation, and then we'll get into a function. So relation is anytime you have a pairing between two variables. So like an ordered pair. So if I have, for example, 2, 1, that's an ordered pair, that's a relation. So if I input 2, I'm going to get out 1. It doesn't matter what I put 2 into, what kind of equation it goes into, it just has to come out with an output. So when we look at a relation, it's the set of all first coordinates is the domain, so the input values of the relation, and the set of all second coordinates is the range. So it's basically just any kind of x, y's. So inputs, outputs. When we look at functions, function is a specific type of relation. So it is a relation, but there's more rules involved. So it has to be, it has to pass a vertical line test. It has to be so that each independent variable is paired with only one dependent variable. So for every input, there's only exactly one output. So what we're going to do is we're going to kind of look at some examples, and we're going to practice identifying are these functions so that you can get to understand the definition a little bit better. And then we're going to also look at the domain and range, so our inputs versus our outputs. So for this first example here, this is considered a table of ordered pairs, so your x, y. So here's all of our inputs. So our domain is just going to be those 4 numbers. So it's going to be 1, 2, 3, and 4. Notice I put the little curly brackets here. That's called set notation. So it's, you use it when you're just trying to list off numbers. The range, the output, well, the only output here is 5. So that's our range. When I look at this one, my only input is 5. Even though it's listed multiple times, it's still the same number. So that's the only input. And for the range, I have all 4 different numbers, 1, 2, 3, and 4. So now if we compare these, one of these is a function and the other is not. So for the function, remember what it means is each input can only have one output. So 1 can only have one possible number that it gets paired to, which it does. It gets paired to 5. 2 can only get paired to one possible number, which it does. It's 5. So for this one, each of these input values gets paired with only one output. So this one is a function, where if I look at the next one here, see how 5 is being used multiple times? That means if I say what's the output to 5, well, you could give me 4 different possibilities. So therefore, this is not a function because 5 has multiple outputs. There's multiple values that are outputted when you input 5. So this one's not a function. So basically, if you're looking at a table, if you look for repeated x values, that would indicate that it's not going to be a function because unless the y values happen to be repeated too, but you're not going to typically see that. So in this case, this would be your scenario when it's not a function. You have multiple of the same x values with all different y values. That's not going to be a function. So if we look down here at the set of ordered pairs, similar to that idea, where if we're trying to determine if this is a function, look at your x values. All the x values are different. So that means they all go to, it doesn't matter what they go to because each x value only has one y value that it corresponds to. So if I say what's the output to 1, everyone's going to respond with 3. So again, we're really looking for that repeated x values. So let me just write that. Look for repeated x values. That's a good way to determine if you have a function or not. So if you have repeated x values, it's not going to be a function as long as the y values aren't the same. So for our domain here, all of our x values is going to be 0, 1, 3, and 5. Our y values, so I'm going to, typically when you do this set notation, you write them in increasing order. So I'm going to say 0, then 1, and then 3, I'm only going to list once. Even though it's repeated, I'm just going to list it once. So this one, and I didn't write that, but this one is a function because I don't have any repeated x values. Every x value is different, so it only goes to one output. So that one's definitely a function. So that's looking at a set of ordered pairs, so set of x comma y's. So now let's go ahead to the next page and let's look at our mapping notation. So that's the next thing. So mapping notation looks like this. So here's all of your inputs, here's all of the outputs. The arrows tell you which ones get paired together. So if I input 0, I'm going to get out 1. If I input 1, my output's going to be 3. So for this, if you're trying to figure out if this is a function, well, look at each of your inputs that all only have one arrow coming from them, which means each of them gets mapped to only one y value. So this definitely is a function. If I look at the next one, see how right here, 1 has 2 outputs. If I ask you what's the output for 1, you could tell me 0 or 3, assuming that that arrow is pointing to 3. So in this case, that means that since this 1 has 2 outputs, this is not a function. There's 2 possibilities, so not a function. And then when we go to look at our domain and range, our domain is going to be the input or the x side of this. So again, I'm just going to list those out. So 0, 1, 3, and 5. The range is going to be the y values or where all of the arrowheads are. So it's 0, 1, and 3. And notice all of these get mapped to. If we look at this next one here, so I'm going to just enlarge this 3 here so that it makes it look like the arrows are pointing to that 3. Notice how 1 doesn't have anything mapped to it, so that means it's not going to be included in the range, versus in the first one, all of these numbers have something coming to it. Over here, not the case. So when we list our domain, well, all of these numbers are being used as inputs, so all of those are going to be part of the domain. And again, I'm going to list them in increasing order. And then when we look at our range, we're only going to list the things that are actually being used. So only listing the things that get used or getting mapped to. So for your range. So there's your mapping. So now if we go ahead down to the graphs here, the graphs we have a little bit more that we have to talk about before we can actually talk about doing the domain and range of the graph. We have to refresh your memory on what's called interval notation. So basically, how are we going to write all of this stuff up? Because on a graph, you have arrows and they're continuous and they go from negative infinity to positive infinity sometimes. You can't list all those numbers. So just a little refresher. Let's just do this right on the top there. You have some space on the top of your page. So just a refresher on interval notation. So let's just write this. So interval notation. If you see something like this with the little square brackets, this means you include the numbers 2 and 5 and everything in between it. So this includes 2 and 5 and all numbers between. So all decimals between 2 and 5. Versus if I write it like this, 2, 5 with parentheses, this does not include 2 and 5. But it does include all numbers between. So what that means is you would get to like 4.99999, not including 5, but really, really close to 5. And then all the decimals in between those. And then for infinity, a little extra note here is if we're trying to talk about infinity, so for negative to positive infinity, so this means all the numbers from negative infinity to positive infinity, all of the numbers in between, so basically every single number, we're always going to use the rounded brackets. So you always use parentheses for these because you can't actually include infinity. You're always approaching it. So that's why it's always going to be rounded. So for these, always use round or open brackets. So for infinity or the round brackets, we call those round, parentheses, open, meaning you're not including the numbers, versus the other ones are square brackets or closed brackets. That means you include the numbers. So now what we're going to do on the graphs below, we're going to actually have to do a little bit of drawing here. So we're going to take the first one here, and we're going to draw out this function. So I'm going to give you kind of some important points to note. So we're going to have an arrow down here. It's going to go up and back down. It's going to come up to a point, and it's going to come down to this point right here, and it's going to bounce back up, and then it's going to come back down. So this point, this highest point, I'm going to say that this is up at 4. And I'm going to say that this point right here is at -2. So when I look at this, notice that I have some peaks and some valleys here. So I have some maximums and minimums. But what we're really looking at is a domain and range. So the domain, see how I will always have an x value being used? This graph is going to just keep on getting wider and wider. So gradually it's going to keep getting wider and wider. And as I look left to right on my page, I don't mean to keep moving this, it's going to keep expanding. It's going to get wider and wider. So I'm going to include all of those values. So for this one, your domain is going to be negative infinity to positive infinity, or you could simply say all real numbers. For the range, you want to look from bottom to top. So it's the y values, what y values are being included. Well, it's never going to stop getting negative because the arrows here are both going down. So that means you're going to have all these negative y values. So it's going to start at negative infinity, and it's going to go all the way up to 4, to positive 4. Since I don't have any arrows going up, the highest point is going to be when y equals 4. So I'm not really using this -2. If there were endpoints on here and that happened to be the lowest, then yes, I would use it. But because there's arrows, it's going to keep going down, and my highest point is actually going to be at 4. So that's going to be my range. Let's look at one more with endpoints, and then we're going to go back and talk about if these are functions or not. So if I draw in another one here, so I'm going to say that this is -5 and -2. I'm going to put a point here. So this is going to be an endpoint. My function's going to come up. Again, I'm just making these numbers up, and I'm trying to place these on the graph nicely. So I'm going to come up to here. I'm going to put an open circle. This is going to be at 2. And then I'm going to come down to -2 and then go back up. So for this one, what ends up happening for our domain is if you look from left to right, so imagine starting at the leftmost point that you include is going to be -5, an x value of -5. That's the furthest left you'll ever go. There's no arrows over here, it stops. So it's going to include that -5, so I'm going to put a hard bracket around that. And then I continue going left, and then I see an opening in my graph. Since there's an opening in the graph, -2 will never be included as an x value. There's no coordinate where -2 is an x value, so I'm skipping that point. So what that means is I'm going to put -2 with an open bracket because I'm not going to include it, but I'm going to include all the points really close to it. And then we put a union just to mean to connect these. That's just a symbol we use to connect. Starting at -2 again, because I want to include all these points right here, getting really close to it. And then keep going to the right. You're never going to stop going to the right on this one. It's always going to keep going, so it's going to go to positive infinity. And then for the range, the lowest point is supposed to be this point right here, which is at -2. So the lowest point's at -2, including that y value of -2. And then the highest point, well, it's just going to keep going because we have this arrow going up, so it's just going to keep on going. So this one will mean infinity. So there's our range. So now, in order to determine if these are functions, the easiest way to do this is what's called the vertical line test. So we can look to see, does each x value only have one y value? That's really what we're doing. So does each input, so does every x value only ever have one y value? And the easiest way to test that is to see if I were to draw a vertical line through these functions anywhere. So let me just kind of show you what that means. So if I were to draw vertical lines through these, see how no matter what, they only hit in one spot? So since they only hit in one spot, these are both functions. So that's what the vertical line test says. So these are both going to be functions because of the vertical line test. What would not be a function would be, so let's just write a couple examples down here. So an example that's not a function would be if I graphed a circle. Because see how if I draw a vertical line through this, there's multiple times that it hits in two spots. So since this hits in two spots, that's not a function. Whatever this x value is, it has two outputs. Even though I can draw a vertical line over here that only crosses once, as long as there's one vertical line that has two outputs or it crosses twice, that means it's not a function. So that's an example that's not a function. Versus any other graph where you can draw and only cross once, so like a parabola, something like that. Let me draw that in a different color. So a parabola, this I can draw vertical lines through it. They only cross once, that is a function. So the vertical line test, often abbreviated as VLT, is if you can draw, so if you draw a vertical line through a graph and it hits more than once, it's not a function. That's what the vertical line tests. And it only works really for graphs if you're graphing it.